Hey everyone, today we're going to be talking about the product and quotient rules. As always, we'll be using some concepts I've mentioned in my previous videos, so if you're unfamiliar with those, be sure to take a look. Alright, so let's start with the product rule. So let's have some function a of r is equal to b of r times c of r. It doesn't really matter what the names of these functions are. You'll probably have to do problems where you won't have actual functions like b of r or j of r or whatever, but it's really easy to just know that you'll have two functions or however many functions for this product rule. So we've established our function. Now, as we've been doing with a lot of other derivative proofs, let's take the natural log of both sides. And the reason why is because we know how to take the derivative of the natural log. So we're going to have the natural log of a of r is equal to the natural log of b of r times c of r. From here, let's separate our logarithm on the right side to have the natural log of a of r is equal to the natural log of b of r plus the natural log of c of r. Now, let's take the derivative of both sides. So we'll have 1 over a of r times a prime of r is equal to 1 over b of r times b prime of r plus 1 over c of r times c prime of r. This proof and the quotient rule proof can get kind of crazy with all the terms, so I did my best to color code everything, but if you need to pause and take a look at the screen or write some stuff down, that's perfectly fine. From here, let's solve for a prime of r by getting it by itself. So we'll have a prime of r is equal to a of r times 1 over b of r times b prime of r plus 1 over c of r times c prime of r. Now, we know a of r is equal to b of r times c of r, so we can replace a of r with that to have a prime of r is equal to b of r times c of r times 1 over b of r times b prime of r plus 1 over c of r times c prime of r. From here, let's distribute our b of r times c of r term to the insides of our parentheses. So we'll have the b of r's canceling on the left term to leave us with c of r times b prime of r, and the c of r's canceling on the right term to have b of r times c prime of r. Now, we could stop here and just have that a prime of r is equal to c of r times b prime of r plus b of r times c prime of r. Kind of a mouthful. But sometimes, or actually most of the time in calculus classes, how they'll have it is written the other way, where you have a prime of r is equal to b of r times c prime of r plus c of r times b prime of r. And the reason for that is because it's usually easier to remember it as the first times the derivative of the second plus the second times the derivative of the first. Sometimes it's known as 1d2 plus 2d1 or lefty right plus righty left. However you choose to memorize it, you can even choose to memorize it in the top equation. It doesn't really matter as long as you know what term is in each place. So that is what we call the product rule. Alright, so now that we've got the product rule, let's switch gears and talk about the quotient rule. Again, let's establish some function x of r is equal to y of r over z of r. You don't really have to label your functions the same way I did. You can choose different letters. For most of the time, we'll probably have to be doing actual functions, but for this proof, I'll just be doing x of r, y of r, and z of r. So from here, again, let's take the natural log of both sides. It's a really useful tool for solving for the derivative rules. So we'll have the natural log of x of r is equal to the natural log of y of r divided by z of r. We'll separate our right part of the equation to have the natural log of x of r is equal to the natural log of y of r minus the natural log of z of r. And from here, we can take the derivative of both sides. What we're going to end up with is 1 over x of r times x prime of r is equal to 1 over y of r times y prime of r minus 1 over z of r times z prime of r. Again, just like the last proof, it's going to get kind of messy on screen, and it definitely gets a lot harder to keep up with your work on paper. So if you need to pause for a second, pause the video and just like make sure your work is fine, that's totally fine. So here, let's solve for x prime of r. So we're going to have x prime of r on the left side equal to x of r times 1 over y of r times y prime of r minus 1 over z of r times z prime of r. Then, just like last time, let's replace our x of r function with what it's equal to, which is going to leave us with x prime of r is equal to y of r over z of r times 1 over y of r times y prime of r minus 1 over z of r times z prime of r. From here, what we're going to do is distribute our outer term into the parentheses, just like we did with the product rule. But remember, this is not the product rule, this is the quotient rule, so you're going to have to end up with something different. So make sure to keep track of what you're canceling and what you're going to end up squaring, because if you're not careful, you could end up having something different. So what we're going to do is distribute our terms, and on the left side of our terms we're going to have 1 over z of r times y prime of r, because the y of r's will cancel. But on the right term, what we're going to have is minus y of r over z of r squared times z prime of r. And that's because on the bottom in the denominator you have z of r times z of r, and there's nothing to cancel the y of r, so you're going to end up with that, kind of messy term there. And from here, what we want to do is kind of clean this up a little bit, because we have two separate terms, but we could multiply the top and bottom of our left term by z of r, and that'll allow us to eventually collect like terms and solve in a much easier way and have a nice quotient rule. So what we'll have is x prime of r is equal to z of r divided by z of r squared times y prime of r minus y prime of r over z of r squared times z prime of r. So as you can see in our left term, we haven't really changed anything. If we wanted to, we could simplify it and end up with the same thing we had last time, but that wouldn't really be doing anything. We'd just be going in a circle. But once we have this, we can subtract the two fractions and end up with what our quotient rule is, which is x prime of r is equal to z of r times y prime of r minus y of r times z prime of r, all divided by z of r squared. Alright, well, thank you guys for watching. I hope that this video was helpful and that you either got a nice refresher or you learned where the product and quotient rules come from. Be sure to comment down below what you want to see in future videos, and until then, I'll see you in the next one.